Hello, my name is Ben Zabriskie, and this is my report for the glider project. The goal of this project was to explore the iterative engineering design process by researching, designing, and building a small glider. We then iterated this design to make improvements to our glider. The requirements were to build a small working glider that had no active control, was made primarily of balsa, would be hand-thrown, would fit in a box 16 by 16 inches, would remain attached for the flight, would go at least 20 feet from being thrown on flat ground consistently. The measures of success for these requirements were that it would fit inside the size limits, be hand-thrown, and fly straight without being actively controlled. It would be made mostly of balsa, not break apart during flight or while landing, and would meet the 20-foot mark or farther consistently. While considering my design, I considered the alternatives of wing shape, wing placement, and dihedral. For wing shape, I considered a rectangular, high aspect ratio elliptical or low aspect ratio elliptical. For wing placement, I considered farther towards the nose, more towards the middle, or farther back towards the tail. For dihedral, I considered no dihedral or dihedral, and if I chose dihedral, I had to consider what angle or how to attach and actually do it. For a rectangular wing, the pros are that it has a large surface area, so it generates a large amount of lift, and it's easy to manufacture. A cons is that it's a large amount of drag. For high aspect ratio elliptical wing, it has less induced drag with a higher aspect ratio, but it's less structurally sound and has less lift because of less area with our limits to the span of this project. For a lower aspect ratio elliptical wing, it has less drag than a rectangular wing while still having a large amount of area to produce a lot of lift. And a cons is that it's hard to manufacture with more induced drag due to a lower aspect ratio. And it was hard for wing placement. It was hard for me to find good sources in my research, so my pros and cons here are anecdotal from my test flights. Farther towards the nose, I found it doesn't stall as easily, but it wants to pitch nose down. More towards the middle, I found that it doesn't want to pitch down as much, but it still does want to pitch down a little bit, and it stalls a little easier. And farther back towards the tail, I found that it was the most pitch stable in my experience, and that it will stall relatively easily. And overall, you want your wing placed roughly above your quarter chord of your wing. For dihedral, I found that dihedral provides greater roll stability due to dihedral, creating more lift on one side that is out of roll alignment and correcting the pitch roll instability. And I found that it was difficult to manufacture and execute, and it was especially at a small scale like this. And I determined that the alternatives that had the highest probability of success were a low aspect ratio elliptical wing, a wing placed more towards the back because we wanted above the CG, and a dihedral with a small angle to correct that roll instability, and a lower aspect ratio ring because it has less induced drag while having more lift. So to size the vehicle, I made the vehicle the full 16 by 16 inch limit so that I could have as much room as possible to get my wing placement correct, to have good pitch stability, and to have as big of wing as possible to maximize my area. In my final design, I made my main wing with a span of 15.8 inches. It had an area of 37 square inches, a chord of 3 inches, and an aspect ratio of 6.7. I sized my horizontal stabilizer to be 15 to 20% area of my main wing because I found this was a good rule of thumb in my research. So I made my horizontal stabilizer with an area of 5.5 square inches, and I made my vertical square stabilizer a third of the wing area at 10 square inches because I also found this was a good rule of thumb in my research. So I made the set of design choices to use a body 6 inches long that would allow me room to test different wing placements, rectangular wings with a chord of 4 inches, and a span of 16 inches to maximize area and therefore maximize lift because lift is directly proportional to area. I chose rectangular wings over elliptical initially due to ease of manufacture. I also sized my horizontal and vertical stabilizers as stated previously, and I tried to 3D print a part, as can be seen here, to test dihedral, but the part did not work. In testing stability in my test flights, here you can see my rectangular wing, and here was its flight. And its maximum distance was about 18 feet. Here's my high aspect ratio elliptical wing. Here is its flight. And its best flight was about 16 feet. Here's my low aspect ratio wing, elliptical wing. And its best was about 21 feet. So overall, I tried to balance the glider to make it longitudinally stable by putting Play-Doh on the front of the glider, as well as adjusting wing placement to get the center of gravity and wing placement correct. However, overall my designs were not very stable, especially in the pitch and roll directions. And again, my test flights did not perform very well against the requirements. These initial flights barely made the minimum distance of 20 feet and were not very stable at all. They rolled almost immediately and made the minimum distance of 20 feet very infrequently. Only on a few test flights were the gliders actually stable, and they were definitely not consistent and failed to meet that consistent distance requirement. To plan my changes, I decided to improve the wing placement and wing shape. After my test flights, it became clear to me that I needed to settle on a low aspect ratio elliptical wing, as it seemed to provide the best balance between high lift and reduced drag, and manufacture that at a thinner balsa to reduce weight. I also needed to change my wing placement, move it farther back towards the tail, as when balanced correctly, this seemed to produce the best results in my test flights. So here's my final design. I moved the wing back and it's now an elliptical made out of thinner balsa, and I sanded to remove mass and decrease drag on the leading edges. Here's some more pictures. So, for my center of gravity, I found it to be 7.25 inches from the nose of my plane, very near the quarter of thy wing, and here you can see my thumb pointing at it, and I just found this by balancing it on my finger. And in estimating the centers of lift, coefficients of lift and drag, I used this equation and found that my angle of attack was about 5 degrees. And converting it to radians, I found my coefficient of lift for a flat, thin plate was 0.5483, and using this graph, I found my coefficient of drag to be roughly 0.005. And so here's my best test flight with my final design, and it went about 25 feet. And here you can see my design within the size limits. And so the design iterations made my final performance much better. I made it much more stable in both the pitch and roll directions, and thus much more consistently flying that longer distance. And my distances slightly only increased to about 27 feet max, but it much more consistently went between 18 and 20 feet, which was a big improvement. And overall, the flight characteristics were a lot better. So my final design met the final requirements. It was made out of balsa. It flew consistently to or past that 20-foot minimum mark. It stayed intact during all the flights, and it was hand-thrown with no automatic propulsion or active control, and it fit inside a 16 by 16 inch box, as you can see here. Overall, this process helped me to learn about the engineering design process, and I had a lot of fun. And I learned a little bit about what it takes to move from something in your head that works in theory and actually make it work and get it to work in real life. And this process also showed that testing and iterating works and is the best way to get out the final design that actually works. To improve my design, I would try dihedral again, as this would likely increase the roll stability of my glider. I would also make my horizontal stabilizer larger, as I believe mine was undersized, and this was partially responsible for some of the stability issues I had. Lastly, I would continue to work to improve the stability, as that seems to be a very important factor in how the glider actually performs. And here you can see my references.